Welcome to Balaya Math Lectures. Learn every step. Today we will discuss the linearly dependent and independent of vectors. Let x1, x2, so on, xn be the vectors and their linear combination can be written as by taking the n scalars. Say lambda 1, lambda 2, so on, lambda n. The linear combination is nothing but lambda 1 x1 plus lambda 2 x2 plus on to plus lambda n xn is called the linear combination of the vectors x1, x2, so on, xn. Now let us come into the definition of linearly independent. When will you say that the n vectors, say x1, x2, so on, xn are linearly independent? If the linear combination is equated to 0, that is lambda 1 x1 plus lambda 2 x2 plus 1 to plus lambda n xn is equal to 0, and if we can obtain lambda 1 as 0, lambda 2 is equal to 0 and lambda n is also 0, that means all the scalars in the linear combination must be equal to 0. If all the scalars are 0, then we can say that the n vectors x1, x2, so on, xn are linearly independent. If the linear combination is equal to 0, that means lambda 1 x1 plus lambda 2 x2 plus 1 plus lambda n xn is equal to 0. If at least one scalar is non-zero, then we can say that x1, x2, so on, xn are linearly dependent. And any one of these vectors can be written as linear combination of the other vectors. So this is the concept of linearly dependent and independent. Let us see some problems to understand the linearly dependent and independent of these vectors. Here is the question. Check whether the vectors are linearly dependent or linearly independent. If they are linearly dependent, then express one of these vectors as a linear combination of other vectors. Here is the problem. 1, 3, 4, 2. 3 minus 5, 2, 2, 2 minus 1, 3, 2. Let me take this is x1, this is x2 and this is x3. Let x1 is equal to 1, 3, 4, 2, x2 is equal to 3 minus 5, 2, 2 and x3 is 2 minus 1, 3, 2. The linear combination of these vectors can be written as the linear combination of these vectors is lambda 1 x1 plus lambda 2 x2 plus lambda 3 x3 and equal this linear combination to 0. That means this is equal to 0. If you multiply this one with lambda 1 plus 3 lambda 2 plus 2 lambda 3 is equal to 0. Yeah, lambda 1 into 1, lambda 1 plus 3 lambda 2 plus 2 lambda 3 equal to 0 and 3 lambda 1 minus 5 lambda 2 minus lambda 3 equal to 0 and 4 lambda 1 plus 2 lambda 2 plus 3 lambda 3 equal to 0 and 2 lambda 1 plus 2 lambda 2 plus 2 lambda 3 equal to 0. Now what is this? This is the system of homogeneous equations. So you know how to solve the system of homogeneous equations. How? First of all, you need to write the matrix form of the given system and then reduce the coefficient matrix into echelon form and then find the rank of the matrix and compare that one with the number of unknowns. If rank is equal to number of unknowns, the system has 0 solution, which means lambda 1, lambda 2, lambda 3 are 0. In this linear combination, lambda 1, lambda 2, lambda 3 are 0. You can say that x1, x2, x3 are linearly independent. And if rank is less than number of unknowns, then the system has infinitely many solutions. That means if at least one of these scalars will be non-zero, the vectors x1, x2, x3 are linearly dependent. Let us solve the system of equations. So 1, 3, 2. 1, 3, 2. 3 minus 5 minus 1. 4, 2, 3. 2, 2, 2. What you have noticed here? the vector which is given is written as a column into lambda 1, lambda 2, lambda 3 equal to 0, 0, 0, 0. Now let us reduce this one into echelon form by applying elementary row operations. So that R2 tends to R2 minus 3R1, R3 tends to R3 minus 4R1, and R4 tends to R4 minus 2R1. No change in the first row. 1, 3, 2. 3 minus 3, 0. Minus 5, minus 9, minus 14. Minus 1, minus 6, minus 7. And 4 minus 4, 0. 2 minus 12, minus 10. 3 minus 8, minus 5. 2 minus 2, 0. 2 minus 6, minus 4. 2 minus 4, minus 2 into lambda 1, lambda 2, lambda 3 equal to 0, 0, 0. Now use this element and try to make these two elements as 0. R3 tends to 14 R3 minus 10 R2, and R4 tends to 14 R4 minus 4 R2. If you do so, no change in the first two rows. So that means 1, 3, 2, 0, minus 14, minus 7, 0, and this is 0. 140 minus 140 becomes 0. 5 14s are 5 10s are 10, 5 4s are 20. Sorry, 5 10s are 50, 5 4s are 20, 70. Minus 70 plus 70 becomes 0. Similarly, this row becomes 0 also, because 4 into 14, 4 10s are 40, 4 4s are 60, minus 56, and this becomes minus 56. So minus 56 plus 56 becomes 0, and this is 2 14s are 28, minus 28 plus 28, 7 4s are 28, so it is 0 into lambda 1, lambda 2, lambda 3 equal to 0, 0, 0, 0. What you have noticed? This is in echelon form. Which is in echelon form. Whenever you have the matrix is in echelon form, you can find the rank of the matrix easily. How? By observing the number of non-zero rows. Here you have two number of non-zero rows. Unknowns are 3. Therefore, rank of A is equal to 2. But less than 3, which are number of unknowns. That means the system has infinitely many solutions, which means your vectors x1, x2, x3 are linearly dependent. Therefore, x1, x2, x3 are linearly dependent. To express one of these vectors can be expressed as a linear combination of the other vectors, you need to find the solution. That means you need to find the values of lambda 1, lambda 2, lambda 3 by writing the equations. That means the system has infinitely many solutions and has n minus r linearly independent solutions. To find that solution, let us write the equations, which are lambda 1 plus 3 lambda 2 plus 2 lambda 3 equal to 0. 2 lambda 2 plus lambda 3 equal to 0. Let lambda 3 is equal to k. Because you have n minus r linearly independent solutions, that means you have to take one variable as a constant. I am taking lambda 3 as k. That implies lambda 2 is minus k by 2. Let us substitute these values in this equation. That means lambda 1 is equal to minus 3 lambda 2 minus 2 lambda 3, which is minus 3 into lambda 2 minus k by 2 minus 2k. So this is plus 3k by 2 minus 2k, 3k by 2 minus 2k, which is minus k by 2. Therefore, your x is nothing but something into k. That something is minus 1 by 2. This is lambda 2 minus 1 by 2 and 1. Now I am taking minus 2 as the value of k. Then this becomes 1, 1, minus 2. These are the values of lambda 1, lambda 2, lambda 3. Then you can express one of these vectors as a linear combination of the others. That means lambda 1 into this thing. That means 1, 3, 4, 2 plus 3 minus 5 is equal to minus 2. Minus 2 can be goes to other side, which will becomes plus 2 into 2 minus 1, 3, 2. Let me take 1 plus 3, 4. 2 2s are 4. Balanced. And 3 minus 5, minus 2. 2 into minus 1, minus 2. 4 plus 2, 6. 2 3s are 6. 2 plus 2, 4. 2 2s are 4. That means one of these vectors can be expressed as linear combination of the other vectors. So this is the way how to verify whether the given vectors are linearly dependent or independent and can be expressed as one of these vectors as a linear combination of other vectors. I request all of you, please like, share, comment and subscribe my channel Balaya Math Lectures. Thank you.